Hi, I'm Chris Mather, and I'm here on behalf of the Cleveland Engineering Society and various other economic development organizations to talk to you about something that really might have a lot to do with your future, particularly if you're in your junior or senior year. And that's the idea of considering a career in engineering. So one of the reasons why we do this is we really love our work. I'm an engineer by training, and I've really enjoyed it. It's helped me immensely in my career. And other people who do this presentation at various high schools have found the same thing, that they're doing different things in engineering, and they really want kids like you guys to know what kind of opportunities that you might have. The second reason is timing. High school is the time that you learn and think about engineering, because engineering is one of those fields that you can do in college that's a little bit more difficult to change into. It's a lot easier to change out of engineering than it is into engineering because of the way the coursework works. So it really is important for you today to think about what you're going to do in the future so that you can make kind of an informed decision about what you're doing. And the other one is to kind of let you in on a secret, is that we think that engineering is probably the best kept secret in terms of what you can do in college, and things are going to change real quickly. I mean, it's only 4 years or 5 years from now that you're going to be getting a job and dealing kind of with the real world. And what you do between now and college and what you do in college will make a difference. And we believe that just not enough kids in this country know about engineering and the kind of careers that you can have with it. So why would you want to be an engineer? Well, one is job satisfaction. I'm glad I'm an engineer. I've actually never done design work as an engineer. My career was mostly in marketing. And then through general management, so I was running companies, but my engineering background has always been there for me. Other engineers actually go in and design things for a while, and they run engineering departments, and they go into various things. But what you'll find amongst engineers, it's hard-pressed to find a person with an engineering degree who isn't glad that they have that engineering training. So we're glad that we do it. And the second one is financial and career opportunities. The opportunities for you as an engineer are amazing. What you'll have with an engineering degree is you'll graduate 4 years from now, and you're almost right now in this country guaranteed a job in engineering. And the salary ranges are running from a low of $45,000 per year to a high of $65,000, in some cases even higher than that, including signing bonuses. In fact, engineering is the #1 undergraduate degree you can get in terms of starting pay. When they list the 10 top undergraduate degrees and getting a job directly, 8 of the 10 are different engineering degrees. Number 1 is chemical engineering, number 2 is computer engineering, number 3 is electrical engineering. I think maybe accounting is sprinkled in there, but literally 8 of the 10 top undergraduate degrees in terms of starting pay with just an undergraduate degree, leaving out the fact that if you get a graduate degree, it's even more money, are engineering degrees. So the opportunities for all of you in working in engineering and really earning a great living are outstanding if you take the time to get an engineering degree. And then the second thing is really that you can benefit society. Almost everything that you touch, everything in this room, everything that's around you has been touched by an engineer. Your car has electrical engineers working on it with the computer systems and the electrical systems. Obviously, mechanical engineers worked on designing the car. Chemical engineers work on the fuel systems. You'd be hard-pressed to find any product that you use that has not been touched by an engineer in some way, shape, or form. So the question is that, do you have what it takes? Well, the question I'd ask is, can you answer yes to any of these questions? Number 1, do you like solving problems? Engineering is really about solving problems. Do you see something and say, there's a better way we can do that, we can fix that, or there's something we can't do today and we can do in the future? So that's the first question. The second thing is, do you like math and science courses? You don't have to be an absolute whiz in math, but it does help to be good in math and science. If you really hate math and science, you should not do engineering, because the curriculum is difficult, and so you're not going to like it. However, if you do like math and science, you're going to find that it's a very, very rewarding not only career, but you're going to like the coursework that you go through. And then the last thing is, do you like the way things work? Are you the person who's curious and says, I see that, here's a new piece of technology that came out, and do I want to know, how did they do that? How did they make that work? Why does it work? If you have that kind of curiosity, you probably have the background to be an engineer. Now, an interesting thing about engineering is that you don't just study engineering by itself. You always end up specializing in one type of engineering or another. And one thing that engineers will often do when they meet, if somebody says they're an engineer, the next question is, well, what kind of an engineer? So in my case, I'm an electrical engineer. So that's the one I start with. So electrical engineers really work on everything that's electrical or electronic in its nature. So this might be something as small as the Pentium chip in your computer. Well, now it's not a Pentium, it's probably called something else, but the microchip in your computer. And it may be as large as the US electrical grid. This is all the domain of electrical engineers. So they're working, electrical engineers are very good systems thinkers. And the reason why is they're working on things that they can't see. I've never seen an electron, but I know what it does. Now, by contrast, a mechanical engineer works on things with moving parts. So everything that you see in any room where you're watching this has a mechanical engineer designing it. And every electrical product, an electronic product that you have has a mechanical engineer working on it. Because like an iPod or an iPhone or an iPad, they're doing a lot of things to make those small and compact. And that's really the domain of the mechanical engineer, as well as things like heat transfer. So you want to make sure that electronic products, if you've ever sat with a laptop for a long period of time, you notice how hot that it can get. Well, managing that heat transfer is part of the domain of a mechanical engineer as well. The next type is a chemical engineer, and chemical engineers really design systems and processes to produce chemical products for a variety of applications. So it's very close to chemistry, but the chemists kind of design the formulation, and the chemical engineers figure out how to often make it in bulk. And so everything that you might think of, so everything from energy to consumer products involve chemical engineers. So oil and gas, obviously a big thing for chemical engineers, but also making cosmetics and other consumer products are the domain of chemical engineers as well. Civil engineers are kind of the easy ones because you think of it, they work on everything that's big. It's all the things that you can see. Roads and bridges and buildings all have civil engineers involved in them. They often design and oversee the implementation of large projects. They work with architects, so the architects maybe do the design of the building. And the joke is in that world is that the architects design the building and then the civil engineers tell them why it won't work, and then they help them work on it to make the building work the way it's supposed to do. Another type is an industrial engineer, and industrial engineers are really process experts. So they understand how processes work in factories or any kind of an environment. So in my case, my son is now an industrial engineer, a recent graduate, and he's actually working on software systems and how they work. So he's not really working in a factory, but you might have a situation like here, you see a factory environment where they're just trying to make our factories as efficient as possible, but you might also have a place like FedEx. So if you think about the amount of packages that FedEx ships every day, and they do it very, very quickly, it's a process. McDonald's hires industrial engineers to figure out how they can serve the tremendous number of people that they do in a short period of time. Another good example is Disney, who's trying to, when you pay the money, they're trying to make sure you get through the lines as quickly as possible, and they hire industrial engineers for that. Now, a relatively new type of engineering that's become very, very popular is biomedical engineering. And biomedical engineering really is the mixture of chemical, electrical, or mechanical engineering as applied to the human body. So biomedical engineers understand those systems. And here in Northeast Ohio, we have a plethora of companies that are working in biomedical engineering, whether it's in medical devices or in pharmaceuticals. Some great examples. Cleveland Clinic worked on a product that will actually counteract the effects of Parkinson's disease. So it can take someone who really is struggling, where they can't live their life because they're shaking all the time. And it literally is a little product that's implanted into the brain, and it actually sends a pulse to counteract the pulse that makes the person shake. And the changes to this person's life are just nothing short of amazing. You see a video from the Cleveland Clinic where the person can't do normal things like pour a cup of coffee, and then all of a sudden you see with the unit turned on, you can barely tell that he even has an issue. That's the kind of thing that a biomedical engineer would do. Now, there are tons of other specialties. Those are kind of the big six. And in most engineering programs, most engineering program at any school that you look at will have all 6 of those in most likelihood, but there's a lot of other specialties. So for example, here in Northeast Ohio, a specialty is polymers and nano-engineered materials. So that is a specialty, particularly here. So that is a part of chemical engineering, but involves some others as well. Structural engineering is a subset within civil engineering, for example. Petroleum engineering, similarly, is a subset of chemical engineering, so focused on the petroleum industry. Environmental engineering, which a lot of people has gained a lot of favor recently, is usually considered to be part of civil engineering. So you're learning how we use water and air and natural resources a little bit better. Fire protection engineering is one. The school that I went to, Worcester Polytechnic Institute, is known nationally for fire protection engineering. In fact, right after 9/11, numbers of people from my school were interviewed about how the fire unfortunately happened in the World Trade Center after the planes hit. But understanding how buildings react to fire and how you can design them in a way to protect against fire damage is fire protection engineering. There's one, for example, my son-in-law is a marine engineer, so he's actually designing ships. So it's just another, it's a lot of mechanical engineering, but it's a lot of systems engineering as well. So there are lots and lots of specialties, and really anything you're particularly interested in from a technology point of view, it's almost guaranteed there's an engineering specialty that handles that. So then there are different kinds of engineers, and so because it's a very, very broad kind of an area. So if you're creative and you like to work in the lab, you want to be that person who designs things. And that's probably 60% of engineering graduates go into design, so they're actually working on a team to design things. Well, in that case, there's lots of opportunity. You can be a design engineer, you can work specifically in product development, or if you're a lot of times software. If you think of the software that you've got in, particularly in video games, they have to be very, very fast. Often that's engineering students that are doing that software design. So that's an area that's easy to do because it's your first thought of an engineer is that you're going to be doing design. But maybe you like really to be hands-on. You like to put things together. You like processes. And in that case, you might want to be a production or a manufacturing engineer, which is part of industrial engineering. You might want to do quality assurance. So you don't want to be testing products before they go out to make sure that they're right and make sure that you can then give feedback to the designers to say we're seeing a lot of problems in this area. So that would be quality assurance. But in other cases, you might want to be a business person. And a lot of people miss this. I went to 4 years of engineering school and then decided I was going to go into what was called technical sales. I did it for a highly technical company, and I'm glad that I did. And I followed that up with working in marketing. And that's something you can easily do. My daughter is a biomedical engineer, and she's working in product management. So she's actually helping plan medical device products. So if you want to work in the business side of things, you can do product marketing, you can be a sales engineer, or you can even be what's called a business process engineer and trying to design various business processes. Or maybe you like to be outside the office. You don't want to be cooped up and stuck in front of a computer. Well, a number of different engineers actually work in the field. So particularly in civil engineering, those guys have to put their hard hats on and go out to job sites all the time. In my case, as a sales engineer, my bosses were encouraging me to be out of the office as much as possible because I needed to be in front of customers working on applications to sell more products. Beyond that, engineers, if you talk to engineers and ask them why they did engineering and how they felt about it, all of them will say that it really helped their career in general. In my case, it did. So my career went from sales to marketing to general management, where I was running companies, and then after that, I've done economic development. And in all those cases, my engineering background has been very helpful to me. I now coach companies, and in this case, I seldom see a technology that I can't understand to the degree that I need. That's what my engineering training does for me so much. But you can do a lot more from engineering. So number one, you can become a manager. And you might become a situation where you're managing other engineers. So if you're going to be an engineering manager, it's 100% chance that that manager of that group is going to be an engineer. So it's not like you take somebody with an English background and have them manage a bunch of engineers. It just doesn't work. But you also might want to do project management. You want to be managing a plant or a lab or manage an entire product line in the marketing side. And you do that, that strong engineering background helps. Or you might want to become an executive. You might want to become CEO or president. Actually, right now, the #1 background for Fortune 500 CEOs is now engineering. It's ahead of finance, which was popular for a while, but engineering is the best background right now to become a CEO, and that's whether it's a CEO of a large company like a Fortune 500 or of a small company. You also might become the Chief Technology Officer, which you're actually working to determine a company's technology thrust and background. Once again, engineering is by far the #1 background for that. Or you might want to become an entrepreneur, and if you're watching this series, you're probably thinking about becoming an entrepreneur. The reality is that the best way to become an entrepreneur is to have a technical background, because most of the entrepreneurial companies, at least the ones that are venture capital funded, are very focused on solving a problem using some kind of technology, and so engineering is almost an ideal background to do that. So what do you have to do to prepare? Well, #1, if you're senior year, you're probably, the die is cast in a way, but I'm guessing that a lot of you have done all the right things. Really what you have to do is make sure you take 4 years of math. If you can do at least pre-calculus, it's good. If you can do calculus 1 or 2, if you can do AP or honors calculus, that's even better. You want to take as much science as you can. But other than that, you're pretty much ready if you have that. You know, you just want to take a college prep kind of a course. In terms of getting into an engineering school, your GPA counts. Standardized tests like the ACT and the SAT are also very, very important, particularly the math sections of those. But also schools are going to look at various accomplishments. It's not all that different than getting into school that you're all dealing with now, but there's just a little bit more consideration on the math to get into a particular engineering program. So in Northeast Ohio, there's tons of choices. Just in Ohio, you've got places like Case Western Reserve University, which is nationally known, tremendous programs at Cleveland State, Youngstown State, the University of Akron, in terms of state schools, as well as Ohio State, Toledo, Dayton, Ohio. I'm not going to read all of these, but there are a lot of choices. The University of Cincinnati is unique because they have a co-op program integrated into their program, which means you go to school for 5 years instead of 4, but you get a full working year where you get paid while you're going to school, and you get paid well. And interestingly enough, that those co-ops usually turn into job opportunities. Over 70% of co-ops at the University of Cincinnati and other schools that either require or offer co-ops turn into job offers. So just right here in Ohio, you've got lots and lots of choices in terms of engineering programs. And you really have to think about, there's a couple ways that you might do this. For example, you could go to what's called a focused engineering university. And those are schools where 60 to 90% of the students are doing either engineering or science. That's what I did. You get some advantages in terms of it being a small school. So I went to a school called Worcester Polytechnic Institute. My daughter went to a place called Stevens Institute of Technology. And to give you an example, so this is a school with 1,800 students, so it's extremely small, on the banks of the Hudson River, overlooking New York City. And I asked my daughter after she was in her first semester, how this worked out. So here it is. She went to a school where there's only 30% women, because engineering is still dominated, unfortunately, by males, but it is changing quite a bit. When I was in school, it was 10% women. Now it's running 25 to 30. And I said, how's it working? How do you feel about you're at this school where you're in the minority and it's almost all engineers? And she loved it. So she said, she was on the lacrosse team, and she said, all my teammates are all doing the same thing I'm doing. They're all dealing with the same curriculum, so we kind of get it. So that was a good, nice, focused opportunity. That's what she wanted. My son, on the other hand, went to Purdue University, which is a huge engineering school, but it's also a big university, and he liked the diversity of lots and lots of people around. So you can find both of that. There's over 300 accredited engineering programs in the U.S., so you can find the one that's right for you, whether it's a university with lots and lots of different degrees where maybe 10% of the students are doing engineering, or it's a university that focuses heavily on engineering where over 50% are doing engineering. And you can find that in huge schools like Ohio State, and you can find it in tiny schools like Ohio Northern. So there's lots and lots of opportunities for you. And then there's a couple of different options. The typical, most traditional way is you go to an engineering school, and it's usually a 4-year program. So you might do engineering. Engineering technology is a little less math focused, so if you're not really into calculus, but you still like the hands-on approach of engineering, engineering technology is often a good opportunity. There's a lot of dual degree programs which do take a little bit more time, where maybe you go in 5 years you get a master's degree in engineering plus your bachelor's. In other cases where you might get a bachelor's plus your MBA. Now another option is to go to a two-year school. So you go to a community college. We're blessed here in Northeast Ohio with a tremendous set of community colleges, all of whom really feed well into the four-year universities. So here in Northeast Ohio, we have Lorain County Community College, we have Stark State College, we have Tri-C, and we also have Lakeland Community College, all of whom offer an easy way to move forward into an engineering program. So if you go for your associate's degree in electrical engineering technology, let's say, you can enter the University of Toledo or the University of Akron or Cleveland State, anybody in the state university system with full credit. So you go in as a junior in your third year into those programs, and the savings are significant. So this can be a great option if cost is an issue, and it can also be a great option if maybe you didn't take all the calculus you should have, and it's a much better way, especially at low cost, to be able to kind of catch up. So what does the engineering curriculum look like? And the first thing I'll stress to you, it's not easy. And I'm not, I would be probably leading you the wrong way if I told you that engineering, there's lots of great things about it. The money is great, the opportunity is great, the careers are great, but engineering is a very challenging curriculum. Typically in your freshman year, all engineering programs look the same. They all offer physics, chemistry, math, and it's pretty prescribed. You're not going to have a whole lot of options other than maybe some of your humanities classes. Now, a nice thing is in your freshman and sophomore, your freshman year, you're doing so little specialization, you can always change from one kind of engineering to another, and most do. In my case, I started as electrical engineering, I moved to biomedical engineering, and I moved back to electrical engineering. And that happens all the time. So at the end of your freshman year, you can go in and say, I'm going to do engineering, but I don't know if I want chemical or mechanical or electrical. It doesn't matter because it's going to be the same. As you get into your sophomore year, you start to take some of your engineering courses. So you still have the ability to change or move, but it's a little bit harder. You might miss one or two classes that you have to take over, but it's still possible. So really, in your first 2 years of an engineering education, you have a fair amount of flexibility to change your major. Once you get into your junior and your senior year, you're taking very specific classes. So a typical electrical engineer might be taking 3 electrical engineering classes plus a humanities class plus another class or 2 that relate, like physics or something, in their junior year. So it's very, very specific. So it's a lot more difficult to become a mechanical if you start as electrical once you're in your junior year. In your junior year, you often do paid co-ops and internships. So as I mentioned, at places like the University of Cincinnati, you have co-op basically says that you're going to go a semester where you work at school, and then another semester where you work at a company like a General Electric, and at very, very high pay rates. To give you a sense of that, typical co-op pay rates are between $15 and $20 per hour. So you can make a fair amount of money during that time that you're a co-op, and then the next semester you go back to school. So you put in some extra time, and over 70% of those co-op and opportunities turn into job offers, so that when you get out of school, you've got one job offer kind of in the bag, because that company has seen you work and you've gotten to see that company, so it's usually a really, really good match. If you don't do co-ops, I would highly recommend in engineering that you do internships. Both of my kids did that. They were going to school outside Northeast Ohio. They wanted to be back in Northeast Ohio for the summers. So each one of them did a different internship at an engineering company. Once again, the pay rates are in anywhere from the $12 to $20 per hour range, so the pay is very, very good for those engineering internships. And typically it's a summer job where you're not working at McDonald's, you're working at a company. So my daughter did 2 years at a very entrepreneurial biomedical engineering company working on a device for evaluating Parkinson's disease patients. And then her last year was at a company called Steris, which is a large medical employer. In my son's case, he did 1 year where he actually pressed vinyl records. There is places that do old-time records, and that's in Cleveland. He worked at a civil engineering company, and he also worked at an electronics manufacturer. And in all cases, the pay was good, but it really put them in a position to be able to get jobs in the future. So I would always recommend that you either do a co-op program or you do an internship program with an engineering education. Lots of places you can work. Actually, a report just came out as I make this tape this week that Northeast Ohio has seen the 7th largest high-tech job growth in the nation, which was great news. And so there are just lots and lots of places that you can work. If you decide you want to work in Northeast Ohio, it's everything from large companies like Rockwell Automation and Steris to mid-sized companies like Gould Instruments, national labs like NASA, or tons and tons of small companies. So I have a list here that you can see on screen And this is just a small fraction of the companies that you might go to work for as an engineer. So if you want to work in engineering in Northeast Ohio, there's lots and lots of opportunities. If you want to work anywhere, not only in the country, but anywhere in the world, the opportunities are pretty endless. And so if you decide that you'd like to work offshore for a while, you'd like to work in Europe, it's extremely easy to do with an engineering background, because right now engineers are in demand, and they're expected to be in demand for years to come. So I want to thank all of you for spending the time watching this, and if you're thinking about an engineering education, I would highly recommend that you talk to someone who's an engineer, contact the Cleveland Engineering Society, talk to your guidance counselor, or even talk to the schools. Colleges that offer engineering, those engineering programs are looking for students like you, and if you contact them, they'll have a lot of information to get you to where you would like to be, and pick the right school, and to make sure you pick a great engineering career that works for you. Thanks.